Hello, and welcome back to Teacher Gimble's channel. Today we'll be going over Illustrative Math, Geometry, Unit 1, Lesson 12. Let's get started. And I apologize that this first question is so tiny, but it's so I can make it fit all on one screen. Hopefully you can see it. Problem number 1. Oh, if you like this video, please like and subscribe. I think the button's over here. Match the directed line segment with the image of polygon P being transformed to polygon Q by a translation by that directed line segment. So we have 4 translations, translation 1, translation 2, 3, and 4. And we know each translation is being moved in a specific direction, over, up, right, left, and for like a certain amount of distance. And these lines describe those translations. Now, what I like to do for questions like this is I find a point that's very unique, and I find where it has been translated to. And I say that point has gone there. In this question, this point here has gone there. And you only need to do this with one point when you're dealing with rigid motion. This point has gone here, and this point has gone there. But I made a mistake because, hold on, these two things look the same. If I read the question more carefully, P was being transformed to Q. So as I was quickly going through this, here P went to Q, P went to Q. This is the mistake I made. Q doesn't go to P, P goes to Q. So always be extra careful with your rigid motion and identifying which one is the pre-image and which one is the image. And in this case, P is the pre-image and it goes to Q, which is the image. And P to Q over there. We've drawn our directed line segments, so now everything else is matching. This long guy, he's going to be U. This guy going at an angle a little bit down, W. This guy going at an angle a little bit up, A. This guy going directly to the right, V. And we're done. And that's how I like to find my directed line segments. I find that very easy and only focus on one point. Because if it works for one point and it's rigid motion, it's going to work for all the rest of them. Let's go on to question number 2. We can zoom in now. Draw the image of quadrilateral ABCD when translated by the directed line segments V. Label the image A as A prime, the image of B as B prime, and the image of C as C prime, and the image of D as D prime. So when I'm going to translate a polygon, which is any shape, instead of every single one of these points that is on the line gets translated, but I'm going to focus only on the vertexes. And I see here in my triangular plane that I go up 2 over 1. So for B, he's going to go up 2 over 1. And that's going to be B prime. A, up 2 over 1 that way. And what I'm saying here is this goes up 2 like this and over 1 like that. So here, it's like up 2 here, over 1 like this, up 2 here, over 1 like that. A prime, always put your labels. C is going to go up and over, which gets me C prime right there. D up 2 over 1. That's going to get me D prime over there. Once I've done that, I connect D to C, so D prime to C prime, C to B, so C prime to B prime, B to A, so B prime to A prime, and then A to D, so A prime to D prime. And this right here, let's make it really obvious, is my translated figure. And we're done. Let's go on to the next question. Problem 3. Which statement is true about a translation? A translation takes a line to a parallel line or itself. Well, we have a line. When we translate it, he's going to be going over here, over here. I actually think that's true. So I'm going to put a little check mark, but I never check my answers before I read every single one of them. A translation takes a line to a line perpendicular to itself. No, it does not do that. A translation requires a center of translation. A translation requires a directed line segment, or a vector, not a center of translation. A translation requires a line of translation. So let's think about this. We have A or we have D. A line of translation is kind of a funny word, and I think that what that's saying is a line of reflection. In this case, I wouldn't necessarily call a directed segment a line of translation, so I think that language is not correct. Which tells me that my initial reaction that a translation takes a line that is parallel to the line or itself is the correct answer. If it doesn't take it to another line, so a translation, I take that line, I translate him over here. But if he translates like right on top of himself, he's going to stay in the same place. So that wouldn't necessarily be parallel. It would just be a translation that lies on top of itself, which sometimes happens. Problem 4. Select all points that stay in the same location after being reflected across line L. So A, going across line L, he's going to end up over here. B is going to end up over here. D is going to go over here. And if we remember, the lines that stay on line L are the ones that start on line L. So F and C, they're going to end up in the same spots. So our correct answers for this question would be C. Oh, that's an E, sorry, not an F, an E. So let me circle that for you. C and E would be the correct answers for this question. Let's go on to the next one. Problem 5. Lines L and M are perpendicular to A. So we have lines L and M are perpendicular. Oh, not to A, perpendicular. A point Q has this property. M is perpendicular to L. Rotating Q 180 degrees has the same center, has this property. If M is perpendicular to L, rotating Q 180 degrees using center P has the same effect as reflecting over line M. So let's think what this question might say. We have a point Q. So Q, oops, that's a way too big of a point. So say we got Q over here. And if we reflected him over line M, Q prime would be over there. And if we rotate Q 180 degrees, Q is going to end up over there. But it says it has the same effect as reflecting Q over line M. So we need to figure out, where does Q live so it has the same effect with the rotation of 180 degrees and the translation? This is a tricky question. So for a question like this, I like to try out a few different options that I think might be the answer and check to see if they're right. My first instinct is that Q is going to live on a line, because we know special things happen when we have our points on the line of reflection. So if Q lives here, a reflection over line M, well, that's going to put Q prime over there too. But then a 180 degree reflection is going to put Q, or I guess this would be our Q, and then our Q prime for our rotation would be down there. So that doesn't work. So I'm going to then say, what if Q is on this line over here? So if we have Q over there, well, when we reflect it, so it's not Q prime yet, that's just Q. Reflected over M is going to get us Q prime over here, and then rotated 180 degrees, also gets us Q prime over there. So there we go. Q could live over here. And if it works for that point, it says give 2 possible locations of Q. It's going to work for any point on the L. Now, will this work for all points in the plane? Well, when we first did it, we saw it didn't work for a point over here, and it didn't work for a point on M. But what we can see is that it does work for points on L, because when you rotate over L, or reflect over M, and then rotate 180 degrees, we end up in the same spot. So it's not all points on the plane that this works for, but it does work for all points on L. All right, pause if you need to go back over this, or think about it for a second as I move on to the next question. Problem 6. There is a sequence of rigid transformation that takes A to A prime, B to B prime, and C to C prime. The same sequence takes D to D prime. So we've done this a few times. And what we do is we say D is in between B and C. So D is going to be in between B and C on the image. It's a little closer to B, so we're going to place him a little closer to B over there. And we're done. Problem 7. 2 distinct lines, L and M, are perpendicular to the same line N. So we've got N, and then we're going to have L, and we're going to have M, and they're both perpendicular. What is the measure of the angle where the line L meets line N? Well, they're each perpendicular, so we're going to say 90 degrees. What is the measure of angle where LM meets line N? I'm going to say also 90 degrees because it is also perpendicular. Sometimes the questions that they ask are just as simple as they seem. So we got to make sure just to read the question carefully and go ahead and figure out what the image looks like. And then it's as simple as it is. perpendicular means it intersects at a 90-degree angle, and so those angles are both 90 degrees. All right, if you have any questions, please let me know in the comments. If you like this video, please like and subscribe right over here, and I will see you in the next one.